Overthinking represents a mechanical misfire of a high-capacity system. It occurs when a sophisticated engine lacks the architectural constraints to handle its own output. We call this the cognitive complexity paradox. High intelligence inherently equips the brain with a massive, high-performance predictive engine. This machinery evolved to map out and simulate complex future scenarios before they happen, ensuring survival by anticipating threats in the environment. A standard cognitive engine approaches a problem linearly, one input, one logical solution. But a high-capacity engine generates exponentially more simulation paths for every single variable it encounters. The flaw here is architectural. Without strict external constraints, this immense processing power actively degrades system performance. Forward-moving logical thought collapses under its own weight, twisting into a circular, infinite processing loop. Overthinking, then, is an engineering problem, an unconstrained system overloading its own central node with a massive surplus of simulation data. To fix this, we need to locate exactly where this system crash occurs physically inside your head. This wireframe highlights the default mode network, or DMN. It is responsible for background thinking, memory retrieval, and future simulation. When operating optimally, it processes clear, logical variables. We call this planning, a straight data line from the problem directly to the solution. But watch what happens when you feed the system highly ambiguous or highly emotional variables. That linear path fractures. The brain automatically attempts to solve raw emotional distress using rigid logical algorithms, which is a structural mismatch. The exact moment that planning function misfires because an emotional problem does not compute mathematically is what psychologists call rumination. The late clinical psychologist, Dr. Susan Nolen-Hoeksema, mapped the parameters of this failure state extensively. She identified a healthy state called reflective pondering. This is analytical, system-focused, and drives steadily toward objective solutions. She contrasted this with ruminative brooding. Brooding is highly emotional, hyper-focused on threats, and heavily self-evaluative. Brooding traps your cognitive engine in a closed circuit, entirely preventing the system from outputting an executable action. The instinctive reaction is to try and shut the engine off completely. That is exactly the wrong approach. Effectively managing this engine requires migrating its processing power away from ruminative brooding and locking it into reflective pondering. To rebuild this system, we have to diagnose the 3 specific ways a high-capacity mind fails under load. The first failure mode is analysis paralysis. Mechanically, this is driven by decision overload combined with an acute fear of a wrong outcome. This chart graphs psychologist Barry Schwartz's paradox of choice, showing how abundance destroys decision velocity. As the volume of options increases, system utility rises briefly, peaks, and then drops drastically. Past a certain threshold, the brain begins treating every additional option not as a benefit, but as a severe opportunity cost. The second failure mode is the rumination loop. Rumination loops are brilliant camouflage. They are unprocessed emotional responses bypassing standard processing filters and feeding directly into a logic simulation node. They disguise themselves as intellectual thinking. You feel productive because you are analyzing the variables over and over, but in reality, you are just experiencing a feeling on a continuous loop. The third failure mode is catastrophizing. This occurs when your imagination is forcibly hijacked by your brain's threat detection network. This hijacked system begins mapping out false negatives, treating highly improbable disaster scenarios as absolute mathematical certainties. Mastering these internal architectures sustains high-level performance under pressure. To continue upgrading your mental systems, subscribe to Growth Systems Daily. We build the operational playbooks that high-capacity people need to scale their minds and their output. Whether you experience analysis paralysis, fall into a rumination loop, or start automatically catastrophizing, the root cause is identical. You are applying excessive processing power to unresolvable data inputs. This brings us to a major professional misconception. High performers often believe they can simply use willpower to command their brain to stop thinking. The neuroscience of cognitive load shows that brute force psychological suppression is entirely flawed. When you slam down a mental barrier to suppress a thought, the neural pathway behind it actually swells and fires with increased intensity. Neuroscientists like Kross and Daniel Levitin have extensively mapped this mental chatter. They found that the active effort required to ignore a thought ironically locks that exact thought into the center of your working memory. The system strain escalates rapidly. This triggers what is known as ironic process theory. To successfully not think about a specific anxiety, your brain must continuously expend bandwidth to monitor whether or not it is currently thinking about that anxiety. That monitoring process actively reinforces the neural pathway, fortifying the very loop you are trying to break. Using intellect to fight your own intellect guarantees a system crash. You cannot overwrite an active neural process with sheer willpower. You must structurally interrupt it using external system constraints. We are going to deploy a 4-part software constraint protocol to fix the hardware loop. Constraint 1 is scheduled worry time. Think of this as a strict containment strategy for the default mode network. Give the DMN a hard 15-minute operational window daily, say at 4 p.m., to process threats. Any catastrophic simulation that arises outside that window must be logged on paper and delayed until that time. Constraint 2 is cognitive defusion. Developed within acceptance and commitment therapy, this is a method to sever your identity from the thought itself. You must shift your internal syntax to create mechanical distance. Instead of saying, "I am going to fail," you state, "I am experiencing the thought that I am going to fail." Constraint 3 is decision criteria presetting. This is the direct countermeasure to the paradox of choice. You must define the minimum viable parameters for success before you evaluate a single option. Once an option meets those preset criteria, you execute immediately without seeking further optimization. Constraint 4 is embodied interrupts. If left unchecked, psychological loops eventually calcify into entrenched physiological states. You use an immediate physical state change, like a sudden drop in temperature or intense, explosive movement, to abruptly shift the brain out of the default mode network and into the task-positive network. Collectively, these 4 constraints operate to rip your brain out of a reactive simulation state and lock it into an intentional execution state. To maintain this newly optimized system, you need one final upgrade. Educational psychologist John Flavel established the foundational concept of metacognition. Metacognition is the mechanical ability to observe and analyze your own thinking processes from a completely external vantage point. The highest form of cognitive control is the real-time recognition of the exact millisecond your brain shifts from productive pondering to destructive brooding. Overthinking is untamed intelligence. When you apply the right constraints to systematize it, you convert your greatest bottleneck back into your greatest professional advantage. Ready to systematically upgrade your cognitive and professional architecture? Hit subscribe. This is Growth Systems Daily, and we will see you in the next framework.